This is part the second half of 2017 question 6 higher level. You got an elastic cord where the constant is, so the spring constant is 250 newtons per meter. Calculate the length the cord would have if Henry was suspended at rest. Okay, so we have Henry, what was he? He was 60 kgs. What was that? That was a 32-meter cord, right? I think, let me just read that question again. 32-meter cord. Okay, cool. So what we want is where Henry's gravity is going to be equal to the spring force. Okay, so that's at rest. Okay, so F is equal to mg is going to be equal to F, which is equal to minus Ks, right? The restoring force is going to be equal to the gravitational force. So mg is equal to, let's forget the minus. The minus isn't important right now because I'm just balancing out numbers, not direction. So Henry is 60 kgs and we're using 9.8 meters per second squared here. And that is going to be equal to 250 times some displacement. So 60 times 9.8 is equal to, divided by 250, and I get an answer of, so the displacement is 2.352. Sorry, just to clarify, S is 60 times 9.8, and I'm dividing them both by 250, just rearranging this. And when you do that, I get a displacement of 2.352 meters. The length of the cord is that plus 32, because that was the original length of the cord, is equal to 34 plus 0.352 meters. Just, it's the 32 of the original plus the 2.352 that is just stretched due to Henry being on the end of it. After the end of the fall, Henry oscillates with simple harmonic motion. The maximum displacement from his rest position is 1.2 meters. Okay. Calculate his maximum acceleration as he oscillates and his period of oscillation. Okay, so the acceleration is omega squared s. Okay, minus, it's a restoring acceleration because it's a restoring force. Okay, I need to know omega squared. What do I need to know about omega squared? Oh yeah, this is this weird thing. This omega squared, remember, is the elastic constant over m. That if you're using real world physics, that's page 148 of real world physics. Yeah, grand. So I know my K is 250. I know the mass is 60, right? All right, so that gives me an answer of 4.16 recurring. And I just have to what was I asked for? Maximum acceleration. I just have to multiply that now by this. A is equal to 4.16 recurring times the 1.2 displacement. 5. Okay, so the acceleration is minus 5 meters per second squared back towards the, it's negative because it's going backwards, so he's going back up, or actually it just doesn't, yeah, at either point it's going to be that. All right, and then the period of oscillation, t is equal to, what is it, let me go back in, t is equal to 2 pi over omega. All right, so I have omega squared, so I'm just going to do 2 pi over the square root of 4.16 recurring. So 2 times pi 1.51 seconds, let's call it. No, that's wrong. I forgot to square root. T is equal to 3.08.